Find the slant height of the following frustum. Alright, so this is not asking us to find a lateral surface area, total surface area, volume, or anything like that. All we're trying to figure out is what is the slant height. And there's a hint. Consider a cross-section and you use the Pythagorean theorem. This is, of course, a three-dimensional figure, but if we did a cross-section through here, then what we would end up getting is something that looks like this. And the distance across the bottom was 15 feet, the distance across the top is 6 feet, the distance from here to here is 5 feet. And where I've drawn this altitude, this 5 feet, is actually pretty suggestive. It makes a little triangle over here. So if only there was some way to figure out what, well, this is the distance we're actually after. This is our slant height. If only there was some way to figure out what this distance is, this one right here, to find that distance. And, well, if we know that this distance up here is 6 feet, let me draw this down here. Let me call it something. Let's call this A. Sure, why not? This distance right here is A, and because of symmetry, you know, this thing spun around, this distance over here would also be A. So it looks like since we have A, you know, two different A's and a 6, in total those should be equal to 15. Well, hey, I could actually solve a little equation there. 2a plus 6 plus 15, or equals 15. And if I was to solve this equation, I get 2a equals 9 by subtracting 6 from both sides. Then divide both sides by 2, I get a equals 4.5. So that means that this side length here is actually 4.5. Now, since this is a right triangle, and I have the two side lengths, I could actually find the length of the hypotenuse, and that's actually the slant height of this particular frustum. So the slant height of this frustum would end up being 5 squared, the square root of 5 squared plus 4.5 squared. Again, that's just using the Pythagorean theorem. S squared would be equal to, I should probably show my work here, S squared would be equal to 5 squared plus 4.5 squared. Take the square root of both sides, we get S is equal to this. So, I'm kind of going backwards. Put this over here. Alright, so that means I can just plug that into my calculator. The square root of, parentheses, 5 squared plus 4.5 squared is 6.72, 6.73. And that would be my slant height. That would be in feet. A little bit of two-dimensional geometry in the middle of all this three-dimensional geometry. The given figure represents a cross-section of a countersunk head rivet. The rivet is made of solid copper, which has a density of 0.324 pounds per cubic inch. Find the total weight of the rivet. So this, in case you can't tell, this is, you know, rivet would be a cylinder down here. This is kind of a squashed view. It's actually a cross-sectional view. This would actually be a cylinder here. You would have a larger, maybe make this dashed back there. If we were viewing this from a slightly different angle, it might look something like this. But that's a cylinder down here, and this is, it looks like a frustum of a cone. Because it's a part of a cone, if this was to go all the way like that, it would be a full cone. But of course it doesn't go all that way, part of it was cut off. So this top part is the frustum of a cone, the bottom part is a cylinder. So when we're trying to find the total volume, we're going to take the volume of the cylinder plus the volume of the frustum. Alright, so the volume of the cylinder, I'm just breaking this down into two parts so I don't have to consider everything all at once. The volume of the cylinder. Well, the distance across here is 0.443, the distance all the way across there. So if we cut that in half, we end up getting the radius. So R would end up being, say, 0.443 divided by 2, which is 0.2215. So the radius of this particular rivet, or of the cylinder at least, is 0.2215. That's the same as the distance up here, because that cylinder remains constant throughout the entire length. And the volume of this would be area times height. So pi r squared times height, which is pi times 0.2215 times the height, which you can see is right here, 1.125. Pi r squared, I forgot to say squared. So this is this number pi times this number squared times 1.125, which gives us 0.1734 approximately. That's a number of cubic inches, I guess. Yep. All those measurements are in inches, so that's a number of cubic inches. The volume of the frustum, and again, I could go back and add more accuracy on this thing later if I wanted, or I could write it in right now, I suppose. I might need that. No, I probably won't need it. I don't know, we'll see. That's the number of cubic inches of the cylinder. The frustum up here, this part right here. Looking at my my list of all my formulas, the volume of a frustum, the frustum of a cone specifically, is 1/3 times r times h times r1 squared plus r2 squared plus r1 times r2. So that means we have, well, let's see, 1/3 times pi, those are known, those are just numbers. The height of my frustum is 0.186. R1, I'm going to take whatever this radius on the top is to be R1. It looks like I need to actually figure that out. That means this is R2. R1 must be 0.823 divided by 2, which is 0.4115. So 0.4115 plus 0.2215, that's the radius of the bottom part. This number down here is the radius of the bottom circle, plus 0.4115, oh, each of those squared, I suppose, times 0.2215. So plug this into the calculator, 1/3 times pi times 0.186 times parentheses 0.4115 squared plus 0.2215 squared plus 0.4115 times 0.2215, which gives us 0.0603. I'm going to, what, the 10,000th place here. Adding those two numbers together, plus 0.1734, gives us approximately approximately 0.2337. And if I convert this, this would be cubic inches. I'm wanting to convert this to pounds, so I'm going to say 0.324 pounds per 1 cubic inch. Inches cancel with inches. We get this number times 0.324, which gives us 0.0757 16 ... I probably should have had some additional accuracy on here. I'm noticing, let's see, this is three significant digits, that's 3 significant digits, this one's 4, that one's 3. I'm probably just going to round this off to 3 significant digits, which gets me just to the other side of that 7. So 0.0757 pounds is my final answer on this one.